Hi students. So in the previous unit, we learned about quadratic functions. Specifically, we focused on the vertex form of a quadratic function where we had y equals a, and then bracket x minus p, and bracket squared plus q. And we practiced how to go from general form to vertex form by completing the square, and we also practiced going from vertex form to general form to by expanding and simplifying and grouping like terms. So we also with the rockets practiced looking at the graph and using our knowledge of parabolas to figure out the equation of a parabola based on pieces of information, whether it's a vertex, another point, whether it's 2 points, something along those lines. So in today's lesson, we are going to practice using the general form to graph the parabola. Now, you could always do a table of values, but as you've probably felt in those first couple of lessons with the last unit, that doing a table of values can be really tedious, and it can also be really frustrating because sometimes you use -3 to +3 and you still don't have an idea of whether it's opening or closing or where the vertex is, and you have to do additional values. And if it's a really big parabola, it can be really big numbers and it's very time consuming, and it's kind of trial and error. So there is another way of using general form to graph or sketch really a graph without using technology. Lesson 1B will be using technology, but this is just sketching on the spot, having an idea of what it looks like. So if you see this graph here, this is a really good method to use when it's a nice trinomial, especially when the number in the A position is a +1, where you can find the magic numbers because you're going to end up factoring this trinomial, okay? So the method we're going to use is called Xavier's method. It really should just be Xavier's method because we're going to use x. We're going to find the x-intercepts, the axis of symmetry, and the vertex. So that's the XAV part of Xavier. And the rest of it just got called that for fun because it's just how we roll in math. We make really weird names. All right, so to speed this process up, I chose a trinomial where the number in the A position is a 1. So we just need to find the two numbers that multiply to -6, and we'll add to -1. Now, if this is something that you're rusty on, remember we did this in Unit 3. We had a review of factoring. Go back to that unit, review those practices, or maybe just rewatch the videos. All right, so the two numbers are going to be -3 and +2 because they will multiply to give you -6, and they will add to give you -1. Now, because the number in the A position is a +1, it means we can slap them straight in to the factor brackets. Now, it means that we can rewrite that equation as y equals x minus 3 times x plus 2. When we're talking about x-intercepts, that means y equals 0. So that means we can actually go from having a function in terms of x and y to having an equation where we can actually solve for something because the x-intercepts happen when y equals 0. So there's two possibilities for this. If this first bracket equals 0, so if x minus 3 equals 0, the whole thing will equal 0. So you just have to rearrange, do some algebra, and find out, well, hey, if x is 3, this first bracket that I've highlighted in yellow will be equal to 0. And yes, the second bracket, which I'm going to highlight in blue, will be equal to 5 because 3 plus 2 is 5. But if the yellow bracket is 0, it doesn't really matter what the blue bracket is because anything times 0 is 0. So that's the first possible answer. Okay. The other one is if x plus 2 equals 0. Okay, so you're going to subtract 2 from both sides. We're going to use a little one-step algebra here, and x can also equal -2. So the first, if x equals -2, the first bracket is going to equal -5, but the second bracket is going to equal -2 plus 2, which is 0. So that blue bracket equals 0. -5 times 0 is still 0. So these are our two x values, which means this parabola has two x-intercepts. And here they are. We've solved them here and here. So when we're sketching, I'm just going to go down to the bottom of the page here. We know that x is going to be 3, so 1, 2, 3. Here's one of my x-intercepts. And we know the other x-intercept happens at -2, so 1, 2, here's my -2. These are my two x-intercepts that I found in the first step of Xavier's method. So the next part is we find the axis of symmetry. Well, we already know the two x-intercepts, and there's 1, 2, 3, 4, 5 units separating them, which means that half of 5 is 2.5. So 1, 2.5 away from the x-intercept on the left, or 1, 2.5 from the x-intercept on the right. And here's our axis of symmetry. And that happens at x equals, well, it's not 2.5, because that's just the distance from each x-intercept where they meet in the middle. So we also went over this, I believe, in the previous unit as well. So to find the axis of symmetry is the middle between the two x-intercepts. So this is where we just add them. So we're going to take 3, we're going to add it with -2, and we're going to average them. So we're going to divide by 2 because there's 2 points. And 3 plus -2 is +1 divided by 2, which you can just leave as that, or you can have it as 0.5. And if we look at where we estimate it to be, does that look like this goes through +0.5? Yes, it does. So we know that's where the axis of symmetry is, where x equals 0.5. The last, so we got that axis of symmetry from the second step of the Xavier method. The last thing we need to do is find the actual vertex. The vertex occurs somewhere on this axis of symmetry. And conveniently, when we know the axis of symmetry, we know the value of x. So we just need to find out what is the value of y, or for y, when x equals 0.5. So we are going to substitute, just want to do that in a different color, substitute the x value for the axis of symmetry, and solve for y. So if y equals x squared minus x minus 6, we want to know what does y equal when x is 0.5. So we're going to put in a 0.5 for everywhere we see an x. So we have substituted the axis of symmetry value in for x to find out what the y value is. All right. So y equals 0.25 minus 0.5 minus 6. Right. And then you're going to add 0.25. You're going to subtract 0.5. You're going to subtract 6. And you should get negative 6.25. So that is the vertex. So if we go down 1, 2, 3, 4, 5, 6, this is about halfway, and half of halfway is a quarter, which is what this is, 0.25. So our vertex is roughly here. Now remember, that is a sketch, so it doesn't need to be perfect, but now we know this opens upwards, which fits our information given to us because the number in this position is positive. And just like with the number in the A position in vertex form, if that number is positive, it's going to open up like that. All right. And the only other thing we can do if we wanted to make it a little bit more exact is we could do like a little bit of bonus confirmation, and that's to find the Y-intercept. Right? To find the Y-intercept, x equals 0. So you're going to put in, if this is our original equation, you're going to put in a 0 for x, which is actually really fast because 0 minus 0 is 0, and minus 6, this number here ends up being what our Y-intercept is. So our Y-intercept is -6. So if we look at how we've sketched it, it should have gone through close or near about -6. 1, 2, 3, 4, 5, 6. So here it should have gone here. I kind of drew it a little bit. I didn't even go through my X-intercept properly on that side. So sketching on the computer screen is apparently not my forte, but that's okay. Safe place, no judgment, except for that one student, you know who you are. Okay, so the vertex we have found occurs at when x is 0.5. That's a 0.5, it just doesn't look like it. And when y is -6.25, the axis of symmetry we already wrote. This x-coordinate was at -2 when x was 0, and this x-intercept happened when x was 3 and y was 0. Okay, and there we go. We've sketched a parabola without technology and without too much of painful calculations or anything like that. And we I have an idea of the shape and the form and the important points of the parabola. So I want you to pause the video here and try using Xavier's method to sketch this graph. Find the x-intercepts, find the axis symmetry, find the vertex, and graph it. Welcome back. So the first thing you're going to do is find the x-intercepts. So to do that, you have to take this lovely trinomial and you have to factor it. So you need to find two numbers that are going to multiply to -18. And those same two numbers are going to add to give you +3. Okay. So if you need help with that, you take all the factor pairs for -18, and you're going to find that 6 and 3 will have a difference of 3. So those are the numbers you want to use, 6 and 3. And when you add them together, you have +3, which means that the large number, which is 6, has to be the positive one, which means a 3 is going to be the negative one. So our numbers are 6 and -3. You can't just slap those in your factor brackets right away because this number here is not a positive one. So you are going to use decomp method, like I'm going to. It's also called factor by grouping. Or you can use box method, which I will not be using here, but have made a separate video on how to do. Okay, so you're going to take your 2x² plus, and instead of 3x, you're going to have +6x minus 3x minus 9. You're then going to factor by grouping. That should be a 3. And so your factoring is 2x minus 3 and x plus 3. Okay, so when you're finding your x-intercept, that means this whole thing is equal to y. When you're finding your x-intercept, it means the whole thing is going to be equal to 0. So I didn't really put that in right away because I didn't really need to. I didn't want it to muddy the waters. Technically, all of this is equal to 0 when we're finding our x-intercepts. So we have two possibilities. We have 2x minus 3 could equal 0. And so then we solve for x. So we get add 3 to both sides, and then we divide everything by 2. So we have x equals positive 1.5 as one of our x-intercepts. And we have x plus 3. Ooh. Don't understand why it does that to me. And then we have x plus 3 could also equal 0. It will also equal 0. And so we're going to subtract 3 from both sides, and we have x equals negative 3. Okay, so these are our two x-intercepts. So we can go ahead on the graph and sketch those. So we have x equals, sorry, I just kind of lost my one. So always when I scroll and accidentally, right, 1, 2, 3, right here, and 1.5. So this is 1, this is 2, halfway between it would be the 1.5. There are our two x-intercepts. The next stage is, and I'll change colors and do this in green, is to do our axis of symmetry. So that's our second step. So we're going to take our two x-intercepts, which is negative 3, and we're going to add them together. So we're at negative 3 plus 1.5. We're going to add them together and divide by 2. This is going to be negative 1.5 divided by 2. I actually did mine in fractions, so because I like to confuse myself when I'm doing notes in real time. This is negative 0.75. So just excuse the fact that I just squished that in here. I haven't been managing my note space very well. All right, so my axis of symmetry happens at negative 0.75, or 0.75 is the same thing as 3/4. Think about how if you have 75 cents, you could have 3/4. The axis of symmetry happens at negative 0.75. So that happens between 0 and 1. Halfway between these 2 points would be a half. 3/4 of the way it would be the 0.75. So I just kind of sketched that down. Your sketches hopefully look better than mine. And we have that last step now. We found our axis of symmetry. And we can say that is when x equals negative 0.75. Nice labels are always a good idea. This x-intercept was at 1.5 and 0, and this x-intercept was at when x is negative 3 and y was 0. So I'm going to label my points right now. I could do it at the very end too. And the last step is to find the vertex. So this is where you sub in this value we just found, which is a negative. I just kind of circled over my negative here, for x in the original equation. Now you could do it in the factored form of the equation, which we have here. However, it's always best practice to put it in the original equation where possible and what kind of might be easier. So I'm gonna just do that work down here. So we're trying to find what y equals when x is going to be negative 0.75. Which is also the same thing as negative 3/4. If you feel more comfortable with decimals, you can work in decimals. That's fine. I'm just going to rewrite this actually down here in smaller because I need to. So everywhere I see an x, I'm going to put a negative 0.75 in. Just going to get this out of the way. And now I'm just going to follow. Actually, no, I'm just going to kind of leave it there. Follow, I forgot to put the square here. Follow order of operations. So I have to square that negative 0.75 first, and then I need to add it. And apparently I didn't write my steps very well. So y equals 2. I have to square that negative 0.75 first, which is 0.5625. I then still have to do all this stuff. Okay. So then I'm going to multiply these, do all my multiplications. So I have a term here that has a multiplication, and I have a term here that has a multiplication. Remember, I have to do my multiplying first before any adding and subtracting. So I'm going to get that y equals 1.125 minus 2.25 minus 9. Now I get to do all that subtraction. Remember, there is a negative in here, and I kind of forgot to write it there. That's why this middle term is negative 2.25, because it was 3 times negative 0.75. And so what does y equal when x equals negative 0.75? It equals negative 10.125, which is the same thing as 10 and an eighth. Or really close to 10 and not as close to 11. So remember, we're sketching, so it doesn't have to be exact. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 11. You should not be drawing your vertex below this other dash. It should be really close to the one that symbolizes or represents the negative 10. Is kind of closer to that. So here's our axis of symmetry. I'm just going to extend it down further. I'm going to redraw my negative 10.125 as being really close to here. So here's my vertex, and that happens when x is negative 0.75 and y is negative 10.125. That's some terrible writing. I apologize. All right, so trying to get this all in the same shot. Now you get to sketch it. The only other thing you can do, especially if you're not very comfortable with sketching, is you could find the y-intercept. Remember, the y-intercept happens when x equals 0. This doesn't go into the Xavier name unless we spell Xavier really interestingly. So we have y equals 2 times x squared plus 3 times x minus 9. If x is 0, that takes out that, which means, and it also takes out the second term, which means our y-intercept is negative 9. So you can also include that at negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here is our y-intercept. That happens when x is 0 and y is negative 9. And you can now sketch, hopefully better than me, your parabola. So again, it opens up. It's been horizontally compressed, so it's a little narrower. And that is the Xavier method for sketching. I would like you guys to try these questions here. Sketching, you don't need to have graphing paper. You could always work online on graphing paper. You could get graphing paper online for free and print it off, or you can just sketch the graph. Again, sketches do not have to be exact. You shouldn't be drawing the vertex somewhere below 15 when you know it's negative, when it's supposed to be around 10. It could be roughly where it's supposed to be, but it doesn't have to be exact. Please let me know if you have any questions. I hope you found this video helpful. I hope you guys are doing well, and I'll talk to you guys soon.